Okay, well, finding the derivative by first principle of a square root function. So we're going to look at a basic parent function, the square root of x. Now the square root of x is, if you understand inverses, then you would understand that the x squared curve comes down, it turns at 0, and then it goes up. And then you've got this inverse function where the inverse of x squared happens to be the square root, and it would look like this. And you would understand that this, on the blue curve, on the square root function, this is negative square root, this is positive square root, is vertical here. The gradient is infinity. Therefore, if we get the derivative of the blue curve, the gradient at the blue curve is vertical. So therefore, we cannot derive it when x equals 0. So what we're going to look at is we're going to look only at the values when x is greater than 0, so that we can derive that blue curve. So we're just going to derive this part from here, not including the 0. This is the curve we are deriving the function, the square root of x. Now we're going to use from first principles, so we'll start with x and the function of x, and we'll go to another point which is just to the right of it, across a little h, as h approaches 0, and the square root of x. We're going to look at the derivative being the limit as h approaches 0 of delta x plus h minus x, that's y2 minus y1 over x2 minus x1. Now let's have a look at just the numerator, which says x plus h minus. Now this is a square root minus a square root. So let us use the rule x plus h minus x over x. Let's multiply that by x plus h plus square root of x, x plus h plus square root of x. So that's multiplying by the unit 1, because the numerator and the denominator are the same. But you'll see a minus b, a plus b, difference of two squares is a squared minus b squared. And that's the numerator. And we've got h over x plus h plus square root of x, and this on the numerator becomes just x plus h, and x square root of x squared is x, and we've got x plus h plus square root of x. Now x minus x cancel, so we've got a h. So we've got h over h. Let's now just bring back the rule which says the derivative equals the limit as h approaches 0 of h over h root x plus h plus square root of x. The h's cancel, and now we can substitute 0, and therefore the derivative would equal 1 over square root of x plus 0 is the square root of x. So that would equal 1 over 2 root x. And so there's the derivative of the function. The function of x is the square root of x, and the derivative by first principles. So this is the derivative by first principles. Until I speak to you again, stay happy.